1944, Normandy, 2 o'clock in the afternoon. An American Sherman tank is knocked out. 2:15, a British repair brigade is nearby, but their bolts don't fit. 2:58, the tank is still a pile of metal, the crew in despair. How did these 58 minutes of technological hell, repeated on hundreds of machines from France to Tunisia, force three nations to forget their pride and create a unified standard? The smell of gunpowder and the screech of incompatible threads. That's what preceded the greatest engineering compromise. Imagine a world without reliable fasteners. Ancient peoples tried to join structures with wedges, pins, and ropes. The Egyptians used copper brackets and wooden dowels when building the pyramids. The Greeks used iron clamps in their temples, metal rods that they poured with molten lead to secure stone blocks. But how do you reliably fasten something that must withstand serious loads while still being removable? The first glimmers of the screw idea appeared in the 4th century BCE. Archytas of Tarentum, an ancient Greek philosopher and one of the founders of mechanics, may have been the first to conceive the principle of screw threads. This man was a true genius. He not only practiced philosophy but also created mechanical toys, including the famous wooden dove that could fly. And then the legendary Archimedes enters the scene. Living from 287 to 212 BCE, he created the famous Archimedes screw for lifting water. This device is still used in some parts of the world today. Imagine, 2,000-year-old technology still works today. This wasn't yet a bolt as we understand it, but the very idea of a helical surface as a tool had already been born. Interesting fact, there's evidence that the screw principle might have been known in ancient Egypt too. Some archaeologists have found remains of wooden wine presses with screw mechanisms, dating to the 1st century CE, but these were isolated cases, not widespread application. The Romans, those practical engineers of antiquity, used bolts, axles, wedge bolts, but mostly without threads. Though there's amazing evidence that they created the first true screws from bronze and even silver. Threads were cut by hand with special tools or even by wrapping wire around a rod. Can you imagine what painstaking work that was? A bronze screw from the 1st century CE is preserved in the museum in Pompeii. Amazingly precise work for that time. But the real breakthrough happens in the 15th century, and not just anywhere, but in mechanisms that changed the world. Johann Gutenberg used screws in his printing presses. Without reliable screw connections, his revolutionary invention might not have worked. The screw in the printing press performed a key function. It created uniform pressure on the paper, ensuring a clear impression. Almost simultaneously, the genius Leonardo da Vinci created detailed drawings of machines for cutting threads. His Atlantic Codex contains amazing drawings of machines that were centuries ahead of their time. He envisioned automatic screw production when most people were still making them by hand. Leonardo even drew a gear system for creating different thread pitches. True genius of engineering thought. In the 16th century, French inventor Jacques Besson created the first bolt-making machine in 1568. This was a revolution. Imagine, before this, every screw was made by hand, taking hours of work. Besson's machine could produce dozens of screws per day. In 1641, the English firm Hindley of York improved his invention by adding an automatic blank feeding mechanism. But here's the problem. Every manufacturer made bolts for themselves. In the 17th and 18th centuries, there were more than 100 different thread standards in Europe. Parisian craftsmen made screws with one pitch, London ones with another, and German ones with a third. Imagine a modern world where every smartphone has its own unique charging port. That's the same chaos that reigned in the world of fasteners. This was a true Tower of Babel of mechanics. Interesting detail. In the early 18th century, carriage bolts with characteristic square heads appeared in America. Why square? The thing is, round heads would spin in the wooden parts of carriages, while square ones held tight. This tradition has survived to our day. Square bolts are still used in wooden construction. In 1760, brothers J. and William Wyatt in Britain introduced the first mass production of screw threads. Their factory could produce thousands of screws per day. Bolts were transforming from custom items into mass products, but the compatibility problem only got worse. Each factory used its own standards, its own thread pitch, its own profile, its own diameter. Repairing equipment became a nightmare. Finding a replacement for a broken bolt in an imported machine was practically impossible. And here enters the true hero of our story, Joseph Whitworth. This man deserves a separate film about his life. Born in 1803 into a teacher's family, he went from a simple locksmith to one of Britain's wealthiest industrialists. In 1841, Whitworth accomplished truly titanic work. He collected and analyzed screw samples from all over Britain. He was like a collector, only of screws. Imagine, this man personally measured thousands of samples, calculated average values, conducted statistical analysis. In an era when there were no computers or even calculators, all calculations were done by hand. His standard was brilliantly conceived. The 55-degree profile angle and rounded crests weren't random. Whitworth conducted numerous tests and found that exactly this shape best withstood cyclic loads and vibrations, perfect for the steam engines of that time. The rounded thread roots significantly increased the fatigue strength of the connection. This was a real breakthrough. The British Parliament officially adopted Whitworth's standard in 1884. Finally, there was a unified language for fasteners in an entire industrial power. The economic effect was enormous. Equipment repair and maintenance costs dropped by multiples. But America, as always, went its own way. In 1864, William Sellers, president of William Sellers & Co., and an influential figure in American industry, proposed his own standard. His thread had a 60-degree profile angle, and crucially important, flat crests and roots. Why flat? Such threads were significantly easier and cheaper to cut on the machines of that time. Sellers was a smart businessman. He understood that in the rapidly growing American economy, speed and cheapness of production were more important than perfect technical characteristics. A classic compromise. Whitworth's thread was technically superior, while Sellers' thread was economically advantageous. Thus began a real battle of standards that stretched over decades. In Germany in 1916, they created their own DIN standard, Deutsche Industrie Normen. The French developed their metric system, Italians, Japanese. Everyone pulled the blanket to their side. The world of fasteners split into incompatible systems, and then the dark times of world wars arrived. The compatibility problem stood at full height. Here's a concrete example. During World War I, the British Expeditionary Force in France often couldn't repair their equipment with French parts. French 75mm guns couldn't be quickly fixed with British spare parts. American trucks supplied to Allies required a special set of tools and spare parts. An even more dramatic situation developed during World War II. Imagine an American Sherman tank broke down in Normandy. A British field workshop is nearby, but bolts from a British Cromwell tank don't fit the American one. Mechanics had to either wait for original parts to be delivered across the Atlantic or jury-rig available parts. Every minute of tank downtime could cost the lives of infantrymen it was supposed to support. Military engineers kept special compatibility logs for parts. Archives preserved documents where it's detailed which bolts from which equipment could be used interchangeably. This was a real science of survival in conditions of technological chaos. Wars became the most powerful catalyst for standardization. The price of incompatibility proved too high, literally measured in human lives. In 1948, after long negotiations, Great Britain, the USA, and Canada finally agreed on the Unified Thread Standard. This was a real diplomatic victory. The standard incorporated the best qualities of both systems: the 60-degree angle from the American system for ease of production, and the rounded thread root from the British system for increased strength. But the world strived for even greater unification. Industrial globalization required a single standard. And here, the isometric thread won. Why exactly this one? First, the simplicity and logic of the metric system. Second, active promotion by European powers, which by then had restored their industry after the war. Third, new industrial giants like Japan chose exactly the metric system. Today, isometric thread is used practically everywhere. Even American automakers are gradually switching to metric thread. It's economically advantageous for global production. And what's happening now? A modern bolt is a high-tech product, the result of the most complex computer calculations. Take, for example, bolts for aircraft engines. They're made from heat-resistant nickel alloys that can work at temperatures over 1,000 degrees Celsius. Each such bolt undergoes X-ray inspection for microcracks. In space technology, they use titanium bolts that are several times lighter than steel ones, but stronger. 1 kilogram of weight in orbit costs tens of thousands of dollars, so every gram counts. Bolts for spacecraft use special coatings that prevent cold welding in vacuum. Without them, bolts could permanently weld to each other. In motorsports, they use bolts made of carbon fiber. They're lighter than aluminum, but stronger than steel. True, they cost as much as an airplane wing, but for Formula One racing, where every hundredth of a second counts, it's justified. So next time you pick up an ordinary bolt, remember the incredible journey it has traveled. This little hero literally holds our entire technological world together. And if this historical investigation hooked you, definitely like and subscribe to the channel. There are many more amazing stories ahead about things that surround us every day.